In this video, we're going to talk about the drill into feature of PerfView. And we're going to use this same profile data that we've been using that was collected on the tutorial example, and we're going to open its CPU stacks and then drill into the tutorial process. And so I'm going to quickly describe what happens in a performance investigation. First, well, you have to check, is this a CPU investigation? That is most of my time is being spent in the CPU? And then I might want to narrow the time range into an area that I truly care about. Once you've done those things, usually the next phase of the performance investigation is to go to the by name view and look at the things that are on the top of it. If this doesn't have if either the things here don't make sense or there are no standouts, they're all 1% of the total, you have a very flat profile, then you have to do something else, and I'll talk about that in another video. But in this case, we don't have that problem. We have one method that's really clearly dominating. What that tells us is that this is an area worthy of additional performance investigation. This is worth optimizing if we care about this whole scenario. Okay, so now I care about datetime now. And let's assume that I'm a developer who owns datetime now. In that case, I want to understand the detail. Now this grouping is in my way because I don't get to see the detail that I want to see. I want to understand why datetime now is as slow as it is. Can I make it faster? But if I were to undo the grouping in this view right here, the problem with that is that if I do that, all the other functions, so all of these other things that I'm doing inside the process, will tend to be, they'll also be ungrouped, and then they'll end up merging in with the other things that I intended to ungroup, and you get mush. And it's actually not too bad in this particular case because this example does only one thing. But most programs aren't like that. They have lots of things going on simultaneously, and so when you ungroup too much, and then you lose track of what's grouped and what's ungrouped. So that's what the drill into feature solves, because I can take a particular set of samples, like this set of exclusive samples. I could have also chosen inclusive samples, but I basically pick a set of samples, and then I right-click on it and I say drill into. And what that does is that brings up a new view, and notice that this view's total metric is the same as whatever I selected upon. So I plucked out, okay, these are the samples that are in datetime now or something that it calls. And so now I want to look at the details associated with that. And so okay, so at this point it really hasn't helped me too much because I still don't have the next level of detail, but all I need to do now is do the grouping ungroup module, and what that will do is that will unwind anything in MS Core Lib, but only for these 4,000 samples. So in other words, if my original program had all sorts of other things that were going on inside of MS Core Lib but didn't have anything to do with datetime now, I wouldn't see those in this view, and that's the power of drill into. See, now at this point, I get to see the next level of detail of what's going on there, and pretty much I'm starting over a new performance investigation. If this profile is too flat, I have to use the techniques that I'll describe in another video to make them to group them together and make them bigger until I get things that are pretty big. And frankly, I've already got some things that are pretty big here, which is get date part is quite expensive, and so is all div. And once you have those, you can another technique that you can use is you can find out who's calling these things, like who called all div, who's responsible for, either I need to drill into all div and make all div faster. Presumably this is a division of a long number. It's a CLR routine that divides two 64-bit numbers. But we can find out who made all those calls, and maybe I can optimize those away. And we can see that, oh, these calls to all div are split, in a certain percentage. Maybe half of them came from date get date part, and then fewer came from these other ones. But this gives me the next level of detail. Similarly, I can look at get date part, double click on it, and I see all the callers of get date part. And you can also see that get date part is called several places. So this thing that we thought was very simple, date time now, is actually fairly complicated. It's got a bunch of internal detail, and there's a really good opportunities for optimization. And PerfView lets you zoom in on just that part so that the person who's in a position to change this code can only look at the part that he's concerned with. So to recap, a performance investigation starts out by looking at your by name view and using some techniques to make a big entry. Once you have a big entry, you usually want to pick one of these and drill into them to find out exactly what's going on, and then ungroup just enough to look at that next level of detail.